Hi, my name is Oğuz Selvi. I am going to introduce our project. System consists of two different parts. They are called the control station and the launcher station. They are wirelessly communicated with each other. Here are the final stage photos of our system. Hardware components of the control station are Raspberry Pi 3 and the LCD screen. Here is the screenshot of our graphical user interface. It is coded with Python by using PyQt5 library. Also, OpenCV is used for capturing the live video stream broadcasted by ESP32 cam on the launcher and displayed on the interface. The GUI have different type of functionalities as they are required by design standards and limitations of the project guide. These functionalities are 8 different direction buttons to make launcher move, firing mode as auto fire or single fire, and firing power as high, medium, or low power. For example, high power option enables DC motors to rotate with a higher RPM value. When the connect launcher button is clicked, control station tries to connect with the launcher station. Raspberry Pi's own Wi-Fi module is used for communication operations. At the end of the presentation, there are some videos shows a better demonstration for GUI experience.
Hi, my name is Ekrem Demir. I was responsible for hardware and software design of the launcher system. We used an STM32F4 board to control the launcher system. This is our electrical diagram of the launcher system. To control the stepper motors, we prepared the stepper motor driver files, which is consist of required functions to control the direction, speed, and shaft angle of the stepper motor. Also, to control the DC motors, we prepared the DC motor driver files, which is consist of required functions to control the speed of shaft using PDM. Furthermore, to control the magazine movements, we wrote some functions to adjust the speed, direction, and angle of the continuous servo motor, which is controlled by two external limit switch to understand the existence of the nerve ball. Also, there is another driver file to initialize the ESP82T66, which is initialized by add commands. Also, these files consist of related functions to process the commands. Then, by using condition functions, the commands taken from the control station are processed here. According to type of the command, related operation is handled in the function, which is consist of functions of the device driver files. Also, to decrease the number of cables and make the circuit good looking, we soldered all circuit elements into the perforated patinax. Thank you for listening.
Hello, I am Tunahan Söğüt. Now let's have an overview of the hardware part of the project. Two Nemo 17 stepper motors were used for pan tilt to make elevation and azimuth movements. Two 4988 stepper motors drivers were used to drive the stepper motors. Two DC motors were used in the launcher and L298 motor driver was used to drive them with PWM signal. In the rack and pinion that push the balls into launcher, one CG90 mini servo that can rotate 360 degrees and two limit switcher was used. A 5-volt regulator was used in the electrical part of the system. An ESP32 camera was used to transfer the image to the control station. The ESP8266 was used to receive commands wirelessly from the control station. STM32F407 was used as microcontroller to control the whole system. 3S11.1 LiPo pil was used to power the whole system. A 100 microfarad capacitor was used to reduce the noise of battery.
Launcher system has two main parts, which are pan tilt and launcher. There is a well-designed pan tilt system for stepper motor on the internet. We took it and designed an appropriate launcher to fit it on this pan tilt. In order to design it, I used a 3D modeler program that is FreeCAD. Capability of 360-degree rotation is needed, so to improve the movement of the system and to decrease the friction, bearing is printed and used. Inside the bearing, there are small plastic weapon bullets. Also, a mechanism of magazine is needed backwards of the launcher, because our weapon should fire in a single shot or multiple shots. Rack and pinion system is used for magazine and it can load up to 6 Nerf balls. To put these balls to the magazine, I designed a half pipe with an open top so we can put our balls inside it and fire.
Oluyor. Herhangi bir bağlantısı yok. Tamamen standart şekilde çalışıyor. Burada kontrol istasyonu var. Arayüzümüz bu şekilde. Buradan kamera görüntüsünü görebiliyorsunuz. Kameramız var planşetin üzerinde. Bu şekilde. Hatta kendimize çevirelim. Bak şu an kendimizi çekiyoruz. Karşı tarafa bir hedef koyduk. Kutu şeklinde hedefimiz var. Bu hedefe atış yapacağız. Photoshop modunda seri şekilde atış yapacağız. Buradan High Power'ı seçiyorum. Atış 3 modu olarak. Photoshop'ı seçiyorum. Şimdi atış yapacağım.